This video is called Getting Ready for Calculus Exponents, and it's part of the Getting Ready for Calculus series that I'm doing. So we start here with a recall, and what we want to recall is what is in this little box here, all right, which is exponent rules. So they should all look familiar because once again, this is not an introduction to exponent rules. This is a getting ready for calculus, which assumes you've already seen this at some point and maybe just need a refresher. And likewise, the problems will be a little more advanced and they'll have a mixture of all of the rules and not just an application of one or two at a time. So the rules are up here. You've got your product rule, which remember, if you have the same base, then we add our exponents. The quotient rule for exponents says that if we have the same base and we're dividing, we subtract our exponents. If you have a power raised to a power, we're going to multiply our exponents. Any non-zero number raised to the zero power is going to be 1. If you have the power of a product, you can think of this as kind of like distributing the exponent, right? You have to raise a to the x and b also to the x. Same thing for the quotient. All right, a will be to the x power, b also to the x power. Negative exponents, that's a big one. I wrote it two different ways. So if you have a to the minus x, you can think of that as 1 over a to the x. But also, if you have a to the minus x in the denominator, you can move it to the top, right? Because if you can think of that as a fraction over 1, you can move it to the numerator and the power then becomes positive. So when it flips across the fraction bar, the power will change sign. And then rational exponents, which are fractions, you can write those in two different ways. You can either the denominator here, y is going to be your root. So in both of these cases, you can see it's the root, but you can raise a to the x power first and then take the root, or you can take the root, the y root, and then raise that number to the x power. So the order there, you can do it either way. So that's just a quick refresh, but let's move down to our practice. I have a few problems for us to do, so we'll kind of go through those and just do a reminder of what these should look like. So let's start with problem number 1. They're going to say to simplify, and in general, simplify means no negative exponents. So we want to make sure that the answers that we end up with would have no negative exponents. And also note that the order in which you apply these rules up above can be changed a little bit, right? So one student might do it one way, another student might apply the rules in a second way, and everybody still comes around to the same answer. So that's possible as well. So the way that I am going to do it might not be the way that you do it, but we still should all match up at the end. So one of the things I like to do if I've got everything raised to a power and you have like a fraction inside, I like to clean that up first. So I like to work on the inside. And particularly with negative exponents, I want to get rid of them as quickly as possible. So like we said above, you can just move them around. So I'm going to rewrite this. Keep my positive 3 for that first one. So I'll have x to the positive 3. But I know y to the negative 2 is going to move down. And then in the denominator, I have an x to the minus 1 power, and I know that can move up. So it's an x to the first power, or we just write x, and then y to the fourth will stay there. And then, of course, all of this is still going to be squared. So continue working inside the parentheses because now I have x to the third times just a x. which will turn into x to the fourth, because that's an x to the first, so we'll add those powers. And then in the denominator, y squared plus y to the fourth will be y to the sixth. And then all of this is still squared. So using the property above, when you have a quotient and it's raised to a power, both the numerator and denominator need to get raised to that power. So this is essentially x to the fourth squared, y to the sixth squared. And so we know we multiply those now because you have a power to a power. So that'll be x to the eighth, y to the 12th. Now, there's no more rules that can be applied, and we don't have any negative exponents. So that's how we know we can stop. And that will be our answer. Okay, so let's keep on going. Number 2. And like I said, you could go and do these a different way. You could show even less steps if you need. I'm just trying to put in a few steps since I'm trying to explain it as well. Now, this one does have fractions, but you see you can't work them all first kind of on the inside like we did over here because each of these parts are raised to their own power. So what I'm going to do here is go ahead and distribute the power. A common mistake is to forget to distribute the power to the constant that's sitting out front. So let's make sure that we write that as 2 to the second power. And then you have x to the third raised to the second. We know we're going to multiply those, so let's go ahead and do it. So we can skip a few steps or combine a few steps, if you will. And this will be y to the negative 4. And then moving on to this next piece, you're going to have x to the third, y to the 12th. And then on the bottom, we're going to have x to the 8th, y to the 4th. Okay, so there's a few steps put in together as one. So 2 squared we know is 4. And then I'm going to combine those x's in the numerator. So x to the 6th times x to the third is going to be x to the 9th. And then y to the negative 4 times y to the 12th. We can add those, so that's y to the 8th. And then you've got an x to the 8th, y to the 4th. And so we know we're going to have a positive x up top when you do 9 minus 8. And then when you do 8 minus 4, you're going to have a y to the 4th as well with that. So this is going to be our final answer for number 2. All right, so let's keep going on. Number 3. We can work inside these parentheses. So I'm going to go ahead and do that. And I'm going to just move all those negative exponents to different positions to get rid of them. And then also that 16 over 4, that's just going to be a 4. So a to the 8th stays where it is. B to the minus 4 is going to go down and become b to the 4th. And then you have a to the minus 2 will become a squared. And then you have b squared. All of this to the 1/2. And we'll just keep going from there. So that's going to be 4a to the 10th over b to the 6th. And now everything is going to the 1/2 power. So for the 4 to the 1/2 power, remember that's going to be like the square root. 10 times a half will be just a to the 5th, and 6 times a half will be b to the 3rd. And so this is really just going to be 2a to the 5th b cubed. Okay, keep on going. Number 4. For number 4, we have a kind of a combination. We need to distribute all of those powers, but at the same time, we could move this one down to the bottom. So I'm going to go ahead and move that x to the minus 3 down, make it an x to the 3rd. And then this is going to become x to the 6th, y to the 3rd. And then down in the denominator, we have an x squared y to the fourth. Okay, looks like that. Let's simplify on the bottom. That's going to be a x to the fifth y to the fourth. And then cleaning this up, I will have x to the sixth over x to the fifth will just be an x in the top. And then here you can think of this a couple ways. If the power is larger in the bottom, then your variable is going to be in the bottom. But you could also think of it as 3 minus 1, which would be negative 1, which is going to move it down to the denominator as y to the 1. Okay, so there's number 4. So we have a couple more, and then you can practice on your own. So for this one, let's distribute our power. So we're going to have 27 to the 1/3. That's going to be x squared, 6 times a third. And then y, negative 3 times 1/3 is going to be negative 1. And just as a reminder that this part really just means the cube root of 27. So that's going to become 3x squared, and then the y will be in the denominator. Okay. And finally, problem number 6. You can work inside the parentheses first. So we'll create a numerator and denominator. So 2 over 4 will just be 1/2. So I'm going to put a 2 here. That x, the minus 1, can go here. You'll have a y squared. X cubed stays, and this is going to become y cubed up top. All still to the negative 2 power. So combining those, we've got y to the fifth, and then that's going to be 2x to the fourth, all to the negative 2 powers. So that is going to give us a negative 10 power for y. Don't forget your coefficient, the 2. So that's going to be 2 to the negative 2, and then x to the minus 8. So that's going to become 2 squared in the numerator, which is 4, x to the 8th in the numerator, and then a y to the 10th in the denominator. Okay, so I hope this was a quick review for you. For getting ready for calculus, you've got to know your exponent rules. They're going to come up. It's the algebra that becomes intense, so make sure you prepare and practice, and we'll see you in the next video.